session we will be discussing about modular programming with functions, or it is just the introduction of function. What is a function, how we can create functions, etc. will be discussed here. In the first session of lectures we have seen how we can do the normal or the basics of the C++. Okay, now we will be discussing about how we can use the functions, why we are using the functions, and how we can use that function in our program. So before that we have to discuss what is modular programming. This is definition for that. Actually, we are splitting the large program into small manageable tasks and assign them independently. It is known as the modular programming or divide and conquer technique. Means what? If we have a large program or large problem, we will divide it into different parts. Let's say we are calculating the NCR. What we will do is we have to calculate what? N factorial divided by n minus r factorial into r factorial. So if you are doing like that, what we need is we have to find the factorial of n. Again we have to find the factorial of n minus r. Again we have to find the factorial of r also, and we have to calculate the NCR. So if we are putting all these what we'll say, all these things like all these factorial of a number, okay, factorial of a number inside a function, and using a function call, if you are calling that function, it will be easier and we can develop independently. Okay, let's say I am creating a function factorial for finding the factorial of a number, and we can just call that function to create it. Okay, so all these things, all these separated tasks can be developed independent of the totality of that program. Okay, so we can do the combinations of these things at a sequence structure, that is a straight line, one by one the program will be executed. Selection structure, as we have seen, if else, if ladder, all those things. And loop structure we can use, or iteration or repetition. Okay, using for loop, while loop, and do while loop, we have done that. We have already seen those things. Okay, so using those things, we can using the combination of all these things, the modular programming can be done. So this is our C++ functions. What is the definition? We can see set of program statement that can be processed independently. Okay, this is a set of instruction actually. So instruction or program statement, we just put it inside a function. Okay, and we are just utilizing, or we are just calling that function for executing it. Okay, in other languages it is known as procedures or subroutines. If we have seen the assembly language, it will be seen as a subroutines. Okay, if you are using that, if you are using the function, we have this following advantages. Okay, redundant code, you know that what is redundancy. Every time if you want to get the factorial, we have to type the same code again and again. If we are doing the NCR, we have to type the code for finding the factorial 3 times. Okay, so we can reduce the redundant code. Same thing, the same set of instructions can be written inside a function. We can call that function. And the second thing is easier debugging. If we are reducing the lines of code, it will be easier for debugging the code. Reduction in the size of the code, as we have seen, the size of the code will be lesser if we are using the function. leads to the reusability of the code. If you have created one function for a specific purpose, this is just like the factorial, this could be used in any other place or any other program in that package. Okay. Achievement of procedure abstraction. Abstraction means what? We are just providing the interfaces to the outside world, and through that only we are getting what we are communicating. Okay. So here we are achieving the procedure abstraction. These are the function components. This we will see it in this section. Okay. Function prototype. Normally 4-mark or 5-mark question they will ask as if this function prototype is asked. Function definition. Function definition is nothing but the declaration and body of the function. Function parameters. Function parameters means whenever we are declaring the function, we have to give some input to that function, that are known as the parameters, and here the formal parameters are there. And in every function there can be, if it is not void, okay, it is returning nothing, there will be a return statement. Okay. And the function call will be there, and in that function call we will have the actual parameters to it. So let's see the example of this thing. So this is an example sample function. It has got the syntax is like this: the return type, function name, formal parameters, and inside that we have to give the function body. The return statement, this is known as the return statement, which is the optional one. Okay. So here in this case the function name is our add int. Okay. And it is accepting two integer inputs, int a and int b. These two, or a and b, are known as what? The formal parameters. And after executing this, it is returning what? An integer typed data. So here we are accepting two integers a and b, and we are returning the sum of those two numbers as integer. Okay. So this is our function body. This entire thing is known as a function declaration and definition. Okay. Function declaration and definition. Okay. So here please write the function prototype for the following. Okay. A function which receives an integer and a floating point and returns a double. So how we will write the prototype means just first line, initial line of that this initial line is known as a prototype. This one with a semicolon, if you are mentioning, it is known as a prototype. Okay. So a function which receives an integer floating point returns a double. So how we will do it? Let's see. So here we have to mention what? The return type is a double. So first you have to mention word double, because it is a return type. Okay. And the function name, let's just say fun is my function name, and how many arguments or how many parameters we needed? 2 parameters. What all things it receives? Integer and a floating point number. So here we can mention what? Int a, comma, float b. Okay. Here we can mention any variable name we can use, and accordingly you have to use inside this function also, inside function definition also. Okay. So this is the answer to the first one, and just check the second one. A function which doesn't receive anything and doesn't return anything. So if it doesn't return anything, the data type is void. Okay. Void, just say the function 1. Okay. And that is accepting nothing, so it can be made like this. Okay. The next thing is next function. The function that receives an array of integer and a float reference doesn't return anything. So doesn't return anything means what? Void. Okay, it is fun3, fun2. Okay, and it is accepting an integer array. It's an array of integer and float reference point. So it is accepting what? Int array. Okay, so int a of something. Okay, comma, then what it is accepting? Float reference point. Okay, so float reference. So this is a floating, this is a prototype for a function which accepts an integer and accepts integer array and the floating point reference number, and it is returning an void. Okay. There are different types of functions. Library functions are there, user defined functions are there. Okay, so functions which is already defined in the libraries, that we can use directly in our program. Otherwise we have to define the function that is known as the user defined function. So function is of two types, which is what? Library functions and user defined function. Okay, first let us see the library function. Just give an example. Let me give you an example. Math.h. Okay. Math.h includes what? All the mathematical functionalities, SQRT, all those things, square root of a number, and finding the absolute value, floor, C, etc., etc., etc. So all sine, cos, tan, all those functions we can use. We can use as a function call from this math library functions. So in Linux, if you have to include a CMath. If you are doing the program in Windows, you have to include what? Math.h. Okay. So in this case, math library functions, we can just call that functions to use them. Okay. So here in this case, there are different math library functions that you can use. Okay, seal will give you, if a seal of 8.1 will give you 9.0, seal of minus 8.8 will give you minus 8.0. Means for the higher value rounds to the highest value. Okay. Now cos of x, the trigonometric cosine of x, where x is in radians. This is the exponential function. exp of x means what? E raised to x. Fabs is the absolute value of x. Okay, if x is greater than 0, it is x. X is equal to 0, it is 0.0, and x is less than 0 means absolute of x is minus x. Okay, have you understood? Okay. Now we can use all these things, and the explanations are here. It is very well defined. Just you have to use it in your program. So now let us use that program example. Okay, so this program I have done it inside a Linux platform. That's why I included what #include CMath. And I have to, let's say I want to get the square root of 4. What we will get? SQRT is a function name, and we have to call it using an argument 4. Okay, what is POW to 2, 4? It will give you 2 raised to 4. EXP of 2, it is E raised to 2. EXP 2 to 2, 2 raised to 2. Log 2, logarithm, natural logarithm of 2. Log 10 to 10 base 10, logarithm of 2. Log 2 to log 2 base 2, logarithm base 2. Absolute value of minus 4.6 gives you what? 4.6. Absolute of 4.6 gives you what? 4.6. And now we will see the user defined functions. The user defined functions that we are going to create the functions. Okay, so this is one of the examples. Very well defined means very useful one. Okay, this is a function for swapping two integers. Okay, so here in this case what will happen is, this is our function definition. I have mentioned the function definition here. What is the function name here? The swap is a function name. It is returning nothing and it is accepting two values. Two values it's accepting. So two integers it's accepting. Okay. So what is happening here inside is, it will swap the x and y values. Okay. And here we can see the program starts from this main. Okay, int x comma y, x is equal to 10, y is equal to 20. Okay, or we can get it from the user. Okay, so it will print what? X is 10, y is 20 in main before swapping. Okay, now what this is known as the function definition, and now we are calling that function, okay, with the actual arguments x and y. So what is the value of x here? 10. What is the value of y? 20. So swap 10 comma 20 is what I am calling. So this 10 and 20 is known as what? Our actual parameters. Okay, and here what will happen is, x is equal to 10, y is equal to 20, and inside this what will happen? X will become y, y will become x. Okay, so x is equal to 10. So now after the exchange or after the swapping, what will happen? X is 20, y is 10 after the swap, inside the swap function. Okay, and in the main what will happen here? It is called by value. Okay, so after the execution, inside the x, inside this main, what will happen? X's value we haven't changed at all. Okay, it will be treated, it will we are sending only a copy of this x here in this function. Okay, so here in this line it will be printing what? X is 10, y is 20 in main after swapping using swap. Okay, so let us see what's happening inside. Okay, so whenever in main regions it will execute. Okay, it will create, in this line it will create two spaces, and what happens here? X is equal to 10, y is equal to 20. So in x's place it is 10, y space it is equal to 20. Okay, whenever it reaches the space called swap x comma y, it is just passing a copy of this 10 to the swap. Okay, so what will happen inside the swap? It will copy, or it will give the x, local x a 10, local y a value of 20 here. Okay, and then what happens? The interchange will happen. So inside the swap function we have our x as 20, y as 10, t as 10. Okay, so inside the swap only we have exchanged the x and y. Inside the main, if you are printing x and y again, it will print only what? 10 and 20 only. Okay, so this is another example of function. Okay, so what will happen? There are two different functions. One is add and one is sub. Okay, in this we are calling the sub using without any argument. So here no arguments, no argument, it is returning also, it is not doing any argument. Okay, so inside is what happening? it's accepting two numbers, to temp1 and temp2, and we are doing what, the subtraction. Okay, so this set of code will be executed in the place of this one. Okay, whenever it's reaching this thing, it will jump to here and it will execute all these things and returns to this point. Okay, and after that what we are doing is, next one, we are reading the temp1 and temp2 here, and now I am calling the function add with the values of temp1 and temp2, which is inside the main. Okay, so I am going to do what? I am going to call this function add with the temp1 and temp2 that is read in the main. So this is also what the call by value only. So a copy of this temp1 will be copied to this, copied to this, and it is returning what? temp1 plus temp2. So the added value will be returned, and this entire thing will be replaced with the evaluated return one. Okay, so it will be printing what addition is, whatever the sum of that two numbers. Okay, I hope you understood this thing clearly. So now let us we have seen the function prototype. So if we are using a function prototype, how we will write the program? So as you have seen before in this program, we have done the function definition above the main. Okay, now let's say I want to define it after the main, but I have to inform the main that this function is defined somewhere in this program. Okay, so for that we are using what? The function prototype. Okay, so here in this case, the swap function definition, where is the swap function definition? It is below the main, and here we are mentioning that we have one function named swap, which is accepting two integers and which is returning nothing in this program. So if we are not mentioning this will give you an error. Okay, so if you are mentioning the like this, the function return type, function name and arguments with the semicolon, if we are mentioning it, it is known as the function prototype. So this is our function prototype, this is our function declaration and definition, and this is our function call. Okay, I hope you understood the basics, all the basics of the function components. Okay, so this is a definition of function prototype. Describes a function interface to the compiler by giving details such as number and type of arguments and type of return values. Okay, so the declaration statement syntax will be what? Return type, function name, argument list, and then semicolon. The function parameters, there are two different parameters, formal parameters and the actual parameters. Okay, so here in this case, we can see these two, this x and y is known as the formal parameters, and this x and y is known as the formal parameters. This is actual, this is formal parameters. Thank you.